Good day, everyone. Welcome to the world of physics problem solving. I'm Maria Celina El Cabiting from grade 12 St. Clement, and for today's video, we were gonna solve some problems about physics. Get ready to explore, learn, and defeat the challenges of physics as we embark on this intellectually stimulating adventure together. So buckle up and let's get to it. And here's the five topics that we will gonna discuss. The first one is the measurements. Second is 1D kinematics. Third is 2D projectile motions. Next is Newton's law. And lastly, vectors. The first is the measurement or the metric units of mass specifically. Converting, ganon. Metric unit of mass. 1 g is equal to 1000 mg. The g stands for grams and the mg stands for milligrams. Then 1 mg is equal to 0.01 g. And then 1 kg is equal to 1000 grams. Kg means kilograms. So let us have an example of converting using these three. First one is the 10 grams is equal to blank mg. To solve for this, we will gonna multiply the 10 grams into 1000 mg. As you can see, 1 mg is equal to 1000 mg. For the solution, here it is. 10 times 1000. Then the answer will be 10,000 milligrams. In 10 grams, there is 10,000 milligrams. Second example is 0.3 kilogram is equal to blank grams. To solve for this, we were gonna multiply the 0.3 kilogram by 1000 also. As you can see in the top, this 1 kg is equal to 1000 g. Here's the solution. 0.3 times 1000 is equal to 300. There is, in 0.3 kilogram, there is 300 grams. As you can see, it is easier. But for the next example, we will make it harder. We were gonna use dimensional analysis to make it harder. Here's the given. 0.017 kg is equal to mg. As you can see, we can convert the kg direct to mg. So, the first thing we will gonna do is to convert the kg into grams. Then, after getting the grams, convert it into mg. So here's the solution. 0.017 kg times 1000 grams over 1 kg times 1000 mg over 1 g. Cancel like terms. Then the mg will be on this. Then the answer will be 17,000 mg. In 0.017 kg, there is 17,000 mg. That's it. It's all about the measurements. Then the next topic is one-dimensional kinematics or 1D kinematics. Here it is. Kinematic is the science of describing the motion of objects using words, diagrams, numbers, graphs, and equations. Kinematics is a branch of mechanics. The goal of any study of kinematics is to develop sophisticated mental models that serve to describe the motion of real-world objects. So here's the equation or formulas we can use in solving kinematics. The D stands for the displacements of the object. The T symbol stands for the time for which the object moved. The symbol A stands for the acceleration of the object. And then the V stands for the velocity of the object. A subscript of I after the V, as in VI, indicates that the velocity value is the initial velocity value. And a subscript of F, as in VF, indicates that the velocity value is the final velocity value. So here's some example or one example of kinematic equation. A jet accelerates down a runway at 5.4 m squared for 7.8 seconds until it finally leaps off the ground. Determine the distance traveled before takeoff. Before solving this problem, the first thing we were gonna do is to write the given first. First given is the 5.4 m squared. Second is the time, which is 13.8 s. And then VI, which is 0.0 ms. And the D, which is we will gonna find. The formula that we were gonna use is the distance. The D is equal to VI times T plus 1/2 times A multiplied by T squared. So, substitute the given values. VI is equal to 0 ms. The time is 13.8 s plus 1/2 times 5.4 ms squared. There is 2 after above the s. I forgot to paste it. Plus 13.8 s squared. We can direct it to calculate the total we can get is the distance traveled is 514.19 m. To conclude this, in conclusion, the distance traveled of the jet before takeoff is 514.19 m. For our second or next topic is Newton's second law. Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables, which is the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object, and inversely upon the mass of the object. As the force acting upon an object is increased, the acceleration of the object is increased too. As the mass of an object is increased, the acceleration of object is decreased. Here's the formula that we can use in getting the second law. F net times M. F net is equal to M times A. M stands for the mass and A stands for acceleration, or A is equal to F net over M. Here are some problems, or one problem about second law. Jade has accelerates at 5 ms squared if the car has a mass of 120,000 g. How much force does the car produce? Note, you need to convert the mass into kg. First, we were gonna write the given. A is equal to 5 ms squared. M stands for 1,200,000 grams. And the F that we will gonna find or solve, or the missing one. As you can see, we need to convert now the mass into kg. So, in converting it, here's the solution. 120,000 g times 1 kg over 1,000 g, because in 1 kg there is a 1,000 grams. Then cancel like terms, and the answer will be 1,200 kg. Now our mass is 1,200 kg. For the formula that we were gonna use is F is equal to M times A. Substitute the given, the formula. M is equal to, the M that we will gonna use is the one that we convert na. 12 kg times the acceleration, which is 5 ms squared. And the answer will be 6,000 N. To conclude that the force that the car produce is 6,000 N. For our next topic, it is the vectors. Vector quantities are often represented by scaled vector diagrams. Vector diagrams depict a vector by use of an arrow drawn to scale in a specific direction. Vector diagrams were introduced and used in earlier units to depict the forces acting upon an object, such as they are commonly called as free body diagram. The resultant is the vector sum of two or more vectors. It is the result of adding two or more vectors together. If displacement vector A, B, and C are added together, the result will be vector R, as shown. Vector R can be determined by the use of an accurate drawn scaled vector addition diagram. Here's the formula or equation that we can use in solving vectors. First is the SOHCAHTOA trigonometric. So means SOHCAHTOA means sine is equal to O over H. This is H, not P. Sorry, it's typo. O means opposite and H stands for hypotenuse. Then cos is equal to A over H. A stands for adjacent. Then tan is equal to O over A. O means opposite and A means adjacent. And also we can use the Pythagorean theorem in solving vectors, which is c squared is equal to a squared plus b squared. Here is the example problem of vectors. Yan. Anna walks 30 km west, then 40 km north, then 20 km east. What is her displacement in meter? In meter. Take note of that. So we were gonna draw the diagram of it. First is the 30 km west and 40 north. 40 north, this one, and then 20 km east. Then the missing is this place. To get it easier to solve, we were gonna solve for the red one, which is this one, this angle. We were gonna find this value to make it easier. Yan, that one. So, ilagay lang natin muna siya sa kabila to make it mas easier to see. Here is as you can see in this second diagram, 40 km, same pa din yun. Di man nag-iiba yun. And then, in this one, we were gonna get yung nasa ilalim, kung ano yung value niya. I just subtract the 30 over 20 time minus 20 km. This is the value of that one. Because as you can see in this first diagram, same na yung value nun. Nung nahati siya, 20 na yon. May natira pa. Since 30 to, ima-minus lang natin siya sa 20 to get the value ng nasa ilalim. Then, yan. Have space for solving. In getting the red one, we were gonna use in getting the hypotenuse, we were gonna use the Pythagorean theorem. It is the same with the Pythagorean theorem. Then substitute the value, 10 km squared plus 40 squared in getting the hypotenuse. Then solve it. 10 will become 100 plus 40 squared will become 1,600. Then the answer will be 1,700. It is not yet finished. We're gonna square root it to cancel out the value of 2 in R. So square root of it. Then the answer will be 41.23 km. But we were gonna get the M, not km. And then in converting it, we will just multiply the 41.23 km to 1,000. And here it is. There is in 41.23 km, there is 41,230 meters. To conclude, Anna displacement in km is 41.23 and in meters it is 41,230 m. And for our last topic is the secondary projectile. A projectile is an object upon which the only force acting is gravity. And there are a variety of examples of projectiles. An object dropped from rest is a projectile, or provided that the influence of a resist is negligible. An object that is thrown vertically upward is also a projectile, or or provided that the influence of air resistance is negligible. And an object which is thrown upward at, at an angle to the horizontal is called a projectile too, or provided that the influence of air resistance is negligible. Projectile is any object that once projected or dropped continues in motion by its own inertia and is influenced only by the downward force of gravity. Here are some or one example of a problem of projectile. A golfer hits a ball with an initial velocity of 20 ms at an angle of 45 degrees about the horizontal. Calculate the maximum height of the ball reaches, the total time the ball is in air, and the horizontal distance the ball travels before hitting distance the ball, and the velocity of the ball just before it hits the ground. Take note that ignore air resistance. For solving it, we were gonna write first the given, which is the VI, initial velocity, which is 20 ms, and the 45 degree. So, we can draw this in a diagram. And here's the diagram. This one. This, so you can see it is the diagram. 20, and nawawala yung dalawa, which is the VIX and the VIY. In getting that, we were gonna use this one. In getting the VIY, we were gonna use sine 45 times 20, and the answer will be 14.14 ms, and this is our VIY. For our VIX, we're gonna use the cosine. Cosine 45 times 20, and the answer will be 14.14 ms. And here's our given now. VI is equal to 20 ms, the degree, which is the 45, VIX, which is 14.14, and the VIY, 14.14 also, and AX of 0 ms, and AY is equal to negative 9.8 ms squared. So, for our solution, we were gonna find first the time. And in getting that, here's the formula that we can use in calculating it. First is yan. Negative VFY is equal to VIY plus 8 multiplied by T. Then substitute the given. Negative 14.14 ms is equal to 14.14 ms plus negative 9.8 ms squared times time. So, reciprocal natin siya. Ililipat natin siya. So, the 14 will be negative. Yan, then solve the first one, which is solve for 14.4 minus 14.4 ms, and then will be the answer will be gonna 28.28 ms is equal to negative 9.8 ms squared times time. Then we were gonna divide it into 9.8 to cancel out the 9.8, cancel out, and then divide it. The answer will be 2.86. It is our total time. Then we were gonna just divide it into two to get the peak. And here it is. Our time of peak is 1.3 s. So in getting the y, or the vertical, here's the solution or the formula that we can use. Y is equal to VIY plus 1 half 80 squared. So distribute the given 14.4 14.14 ms times we were gonna use the 1.43 s plus 1 half times negative 9.8 ms squared times 1.33 s squared. Kasi, kaya 1.3, the peak, it is in the ground. It is vertical. So, y is vertical. So, we were gonna use the 1.3. It is pababa, kaya ayun yung kukunin natin. Then, the next we can solve is, we're gonna times the 14.14 times 1.3. The answer will be 20.22 ms squared. Then, multiply 1 half by negative 9.8 ms squared. The answer will be negative 4.9 ms squared, and squared the 1.43 squared. The answer will be 2.02 s squared. So, the next thing to do, to multiply the two numbers in the side. The answer will be 9. The answer will be negative 9.99 s squared. Then we were gonna add these two. The answer will be 10.23 m. The 2 s squared will be cancelled, so the m yung may iwan, so m yung gagamitin nating unit. In getting the x, which is the horizontal, here's the formula that we will use. X is equal to VIX times the time. The time we will gonna use this is the total time, which is the horizontal one. Yan. Distribute the value. 14.4 ms multiplied by 2.86 in getting the x. So, the answer, we can direct it in calculus. So, the answer will be 40.44 m. So, here's the horizontal, then the vertical, and then earlier we tackled the time and the total time peak and the height. So, here's the end of our discussion. I hope you learned something and Hope you enjoyed this video. See you our next vlog. Thank you very much. Bye-bye.